Years ago, when I was lucky enough to work on large, sprawling e commerce systems, I was tasked with integrating a tax calculator into the checkout process. I was handed a diagram of the entire system, and whoo boy, my eyes glazed over. Architecture diagrams, they're an important communication tool, but sometimes they're very complex and overwhelming. Kind of like this one. In my case, calculating tax required data from various external systems in steps in the checkout flow, and I had to unwind it all to figure out how, when, and where to get the data. But what if I could have just had a conversation with this diagram? What if I could have understood it quicker? What if I could get custom recommendations for my system, use real time data and best practices from my company, and even generate new and updated diagrams? What if I could have just asked when and where to get that data for the tax calculator? Hey there, I'm Jenna, and today I'll show you how I built an app that helps me do just this. Let's get started. We'll do this in Python using the Amazon Bedrock Converse API so we can carry out a conversation back and forth between a large language model and the user. This is actually going to support our use cases in future episodes too, when we use tools and incorporate knowledge bases. But right now, let's focus on the chat capabilities using an architecture diagram. We'll first analyze this diagram that visualizes a simple serverless application that generates joy from fluffy puppy memes. Very important business. And then we'll take a look at the tech behind it. We'll start by running our app at the command line using Python. And this is going to output some instructions to the screen telling us how to interact with this application and what it needs in order to move forward. That first thing that it needs is going to be this architecture diagram that we're going to chat with. In our case, we're just going to use the sample diagram, fluffy puppy joy generator, and we'll enter that in, and then we add our query. This is the question that we want to ask our diagram, and this along with the image will be sent along to the LLM, and then we'll get a response back. So I've added some sample queries in here, and we'll just use the first one here. List the AWS services that are in this diagram. And this is going to send the query to the model, and it's going to respond back with some information for us. In this case, it's just a simple list of the services. So Amazon S3, Recognition, Lambda, and CloudFront are all a part of this diagram. There's a number of different sample queries here that we can use. This is just to demonstrate what the different possibilities are that you might want to chat with your diagram. We'll do another one here. How about what are the recommended strategies for unit testing this architecture? This one is going to output a little bit more information to the screen. It's going to give us the unit test strategies that it believes would be good for testing this architecture. So here we go. We have 10 different strategies, and it's looking at the different parts of this diagram and making recommendations based off of what it knows. And so we've got different approaches here. So we've got some different testing that we can do for the AWS Lambda function, some different integration testing. We could also test the infrastructure as code, some security testing, and more. So we could another one of those samples. I'm not going to run this one, but another sample question is: does this adhere to the AWS Well-Architected Framework? We could generate another diagram from this. We could actually generate a sequence diagram using the Mermaid diagramming tool, and we could look at different quotas for the different services that are a part of this, and more. The next thing I want to do actually is I want to take a look at how we implement this functionality. So in future episodes, we're going to learn how to customize this app to fetch data from real-time data from whether it's other systems or the actual physical or virtual resources that we're using, um, or uh, looking at how to incorporate maybe our our company's custom best practices, customizations into this conversation as well. But first, we're going to look at just the basic back and forth chat functionality with this diagram. So I'm going to open up the main class here, which is the architecture chat demo class. And the first thing we're going to look at is the system prompt. This system prompt is telling our LLM how to behave, like what you're an expert in. So in this case, we're saying that you're an AWS solution architect who can answer questions about an architecture diagram. Then we're going to initialize our class. We're setting that system prompt. And then we're initializing the Bedrock runtime client as well. We're saying we want to use the Bedrock runtime, and we're using a specific region. This region, we're getting this one out of our environment variables. Now, this big run function is kind of the big piece of this class. This is the one that coordinates all the different work between collecting the information from the user, collecting that image from the user that we want to chat with, and then also outputting information to the screen once we've actually had that conversation with the LLM. The first thing that we do here is we're actually going to collect that architecture diagram, the image that the user wants to chat with. We use that. We just get that as user input from the command line, and then the next thing we do is get the query that they want to ask that architecture diagram. And then we have this while loop that goes through, and as long as the user is asking questions, it's going to keep carrying on this conversation using Amazon Bedrock and using that Converse API that I mentioned earlier. So here, the first time through, we're going to have an architecture diagram, and we will read in that diagram, that image as bytes. And we prepare this message. And in this case, we're preparing a message that has a role of user, because this is something the user is sending along to Amazon Bedrock, versus if Amazon Bedrock was sending us a response back, this message would actually say assistant here. And then in addition to the role, we send along the content. So here we're providing the image with the bytes. And then we're providing the actual prompt that the user with the user's question in there. This first time through, we're just forcing it and saying, "Hey, we're referencing this image, and this is the question, and I want you to ask this question of the diagram." So that is just preparing the message. Down here, once we have that message prepared, we add it to our conversation. This conversation that we're keeping track of is the piece that we send back and forth between our app and Amazon Bedrock. It's our conversation history. So just like you and I have a conversation, and we know what has been said, what is our history, that's exactly what this is about. This is our conversation history. So we send that along to Bedrock, and I'll just jump in here. This is a pretty straightforward function here, the send conversation to Bedrock function. We're outputting just a little bit of status information to the screen so that the user knows what's happening. And then we invoke that Converse API. We're sending along the model ID. In this case, we're using Claude Sonnet 3.5, but you could change this if you wanted in the code. And then we're sending that conversation along that we prepared. And then we're also passing that prompt as well. When this returns, we actually have to process the model response. So we'll jump into this function here, process model response. We're sending along the Bedrock response, the conversation, and here is where we actually add that response to our conversation, because like I said, when we want to keep sending along this history back and forth. And so now that we've got a response back, we add it to our conversation so that we retain it. So if the response comes back as the stop reason that comes back as end turn, meaning nothing else is happening here. This is the end of this part of the conversation. Uh, then we're going to output that response to the screen. This is the LLM response that came from Bedrock. Uh, we are just grabbing the text part of that response and printing it out. So when we asked what services are used in this diagram, it came back and said it's using S3, Recognition, Lambda, and CloudFront. That's what was output here. So that is pretty much it. Uh, now that now that we have all of our code here, we have this app that lets us chat with our AWS solution architect, and we can do this by chatting with this diagram, and we're able to ask questions so that we can get some deeper insights. Maybe we can make some decisions. And I know I showed you like a really complex diagram earlier. Hopefully, this way of having a conversation with your diagram using natural language can help you reduce the complexity of that diagram. By chatting with your architecture diagrams, from deployment diagrams and data flow diagrams to class and sequence diagrams, whether you're chatting with the image itself like we did today or the markup behind the diagram or modeling tool, you can use generative AI to gain deeper insights and plan for the future. You can start to understand the system as a newbie to your team, communicate changes, evaluate the accuracy, get recommendations and evaluate trade-offs, and even generate new and updated diagrams. But there's one thing that I discovered in building this today is that my conversation didn't actually reflect reality. How much joy is actually being generated by these fluffy puppy memes? We'll dig into this in the next episode, where I show you how to fetch real-time data, like the joy count, from external systems. Are you ready to try this out yourself? Grab the code and the blog post in the description and start chatting with your architecture diagrams. And if you enjoyed this video, be sure to subscribe to the AWS Developers channel for more videos like this video, and share it with your friends. See you in the next video where we look at tools and function calling.